Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 11 of a unit motion in a plane. In today's class we are going to discuss about the previous year asked questions. This is the last section of this unit. It's a motion in a plane. So if you have not revised motion in a plane yet, please pause this video or stop this video and again revise the complete unit starting from the vector and ending with the relative velocity of an object in 2 dimensions. So if you have not revised it, please, it's a humble request, please go through it and then attempt this questions. If you have done it, let's have your pen and paper, be ready with the questions. You are supposed to start the questions as question arise. You need to pause the video. If you cannot do that questions, I am always there to help you guys. So let's begin and all the best guys. Let's have a look. The question is the position of a projectile launched from the origin t is equals to 0 is, this is the position at from t equals to 0. It has been launched at from the origin and the position is 40i plus 50j at t is equals to 2 seconds. It says if the projectile was launched at an angle theta from the horizontal, then theta, I required angle of projection. So how can I do this? So let's suppose what I have given, it's an r is equals to 40 I cap plus 50 j cap. Let's just compare this with r is equals to x of I plus y of j. Now if I compare this, I can have it's an x is equals to 40 and y is equals to 50. Now I know that the motion in the x direction, it is having no force. That means acceleration is equals to 0, or I should say ax is equals to 0 and ay is equals to minus of g. So for motion in the x direction, I can write like this: x is equals to u cos theta into t, which value would be a 40, and for y, it's a y is equals to u sin theta t minus of half gt square, which would be equals to 50. Is it clear up till now? Is it? Great. So if I put the value at t is equals to 2 seconds, because x is equals to u cos theta multiplied by t. So x was the 40 and let just replace the value. It's a u cos theta into 2, that should be equals to 40. That means u cos theta is equals to 20, and y, it is equals to u sin theta into t minus of half into g into t square. This y were the 50. This is equals to u sin theta multiplied by 2 second minus half into 10 into 2 square. So if I solve this, I get u sin theta is equals to 35. Now what do you require? You required tan theta, which can be written as vy divided by vx or ux, both are the same thing. Vy, that means it's an at t equals to 0, it is basically a u sin theta, and ux is always u cos theta. So I am having a value of u sin theta which is 35, having a value of u cos theta which is a 20. It's a 7 5s and 4 5s. So this is 7 by 4, so theta is equals to tan inverse of 7 by 4. Is it clear? Is it? Any doubts? No? Great. Let's move to the next question. Do it quickly. What they say is the initial speed of a bullet fired from a rifle is 630 meter per second, and the rifle is fired at the center of a target which is 700 meter away at the same level as the target. Now what do you require? You required how far above the center of the target the rifle must be aimed in order to hit the target. So how can you do this? If you wish, you can read it one more time, but how it can be done? how it can be done. What can be done? Yes, what they say is the initial speed of a bullet is, it is given u is equals to 630 meter per second. Range is given and height is taken. So the situation is something like this. Let's suppose this is your target location. So you want to hit the bullet at this position, and this range is of 700 meter. This range is of 700 meter. So if you want to hit at this place, you must aim your gun at this position so that it can hit at this situation. I hope those things are clear. So this is the range and this is the height. With this initial velocity you have launched it, and the initial velocity was 630 meter per second. So now r, it's a range, is equals to horizontal direction velocity multiplied by time of flight, and time of flight can be written as root of 2h by g. This r is 700, this ux, it's a 630 multiplied by root of 2h divided by, let's take it 10. It's a, this 2 would be a 0, it's a 70 by 63. This is equals to 2h by 10 in a square root. Let's take it the square, it's a 70 into 70 divide by 63 into 63, and this is equals to 2 into h divide by 10. So this is 70 into 70 into 10 divide by 63 into 63 equals to, this is equals to 2 into h. So the situation will be, it's a 9 into 7, again it's a 9 into 7, this is 7 into 10, this is 7 into 10. Yes, the 7 has gone, and the term that remains here, it's a 10 10 10, it's a 1000 divide by 81 equals to 2 into h. So h should be equals to 1000 divide by 81, 2's are, it's a 162 meter. I hope those things are clear. Is it clear? Is it clear? So can you do this? This h is equals to 1000 divided by 162 meter. Got it? Ready for the next question? Ready? Let's have a look. What the data is. It says that the maximum range of a bullet fired from a toy pistol mounted on a car at rest is 40 meter. What will be the acute angle of inclination of the pistol for the maximum range when the car is moving in the direction of firing with a uniform velocity of 20 meter per second on a horizontal surface? So first, let us understand the situation that if a car is at rest, its range would be equals to a 40 meter. But now the situation is, if the car is moving in this direction, you need to find out that when the car is moving in the direction of firing with uniform velocity 20 meter per second, you need to find out the maximum range. That means even car is moving, let's say, with velocity v1, and it has been thrown with speed of 20 meter per second with certain angle theta. So now range would be equals to, look at this, this is 20. Yes, for this it's 20 cos theta, and this is 20 sin theta. So its range would be equals to 2 multiplied by horizontal direction velocity multiplied by vertical direction velocity divided by g. So this is equals to 2 into horizontal direction velocity. Now look at this, 20 cos theta is in this direction. Even a v1 is in this direction. So this is 2 into v1 plus 20 cos theta multiplied by uy, that is of 20 sin theta divided by g. This should be the range. I hope those things are clear. I did the same thing. This r is equals to u plus u cos theta multiplied by 2 into u into sine theta divided by g. So if I solve this, it's a 2u square into bracket 1 plus cos theta into sine theta by g. Now what do you want? You want that what will be the acute angle of the inclination of the pistol for a maximum range. Can you see this? For maximum range you need to have maximum value of this bracket 1 plus cos theta into sine theta, because all the other terminologies is a constant. So this is to be maximum, and we need to find out a value of an angle at which this, it's a sine theta into bracket 1 plus cos theta, could have a maximum value. So for that I need to use a concept of maxima minima. Yes, it's a d by d theta of sine theta into bracket 1 plus cos theta that needs to be 0. So this is equals to d by d theta of sine theta plus sine theta into cos theta equals to 0. Now you might know that it's a sine of 2 theta, which is 2 sine theta into cos theta. So if it's a sine theta into cos theta, this is equals to 1 by 2 multiplied by sine of 2 theta. So this is sine theta cos theta, that should be is equals to sine 2 theta by 2. You need to differentiate this with respect to theta. This is d by d theta of sine theta plus sine 2 theta by 2. So how could you do this? It's a d by d theta of sine theta plus sine 2 theta by 2. So if we solve this, differentiate this, it's a sine theta which can be written as d by d theta of sine theta. What is it? Differentiation of sine, it's a cos. Yes, it's a cos theta plus 1 by 2 into bracket sine 2 theta. How could I differentiate this? Sine 2 theta. How could I differentiate this? It's a cos 2 theta multiplied by 2. Yes, this has gone. So this is cos theta plus cos 2 theta, and when I write cos theta plus cos 2 theta, it is cos theta. Cos 2 theta can be written as 2 cos square theta minus of 1 equals to 0. So if I simplify this, it is 2 cos square theta written over here plus cos theta written over here minus of 1 equals to 0. So this is the quadratic equation, and I can compare this with ax square plus b into x plus c equals to 0. If I get this, it's a minus of 1 plus or minus under root of 1 plus 8 by 4. So I am having minus 1 by 4 plus minus 3 by 4. So this is equals to minus 1 or 1 by 2. So cos theta minus 1, it is 180 degree or 60 degree, and cos theta equals to half, it's a 60 degree. But according to the data, you require an acute angle. That means theta is equals to 60 would be the correct answer. I hope you did it. Yes, did you understand this? Do you? A very, very good question, and very, very logical question, which covers multiple concepts at the same time. Is it clear? Great. So shall we have something like this? This was the situation. Let's suppose that this is V1 and object has been projectile with V2 while making an angle theta. So now it's a horizontal velocity. This is V2, this is V2 cos theta, and this is V2 sin theta. So range can be written as 2 into ux into uy divided by g. This is equals to 2 into ux. What is it? It's a v1 plus v2 cos theta multiplied by uy, which is a v2 sin theta divided by g. This could be the range. Now what is hmax? The hmax is u square sin square theta. That is only responsible component for hmax. It's a uy only. So this is uy square by 2g, and uy square has not any change, so it is v2 square sine square theta divided by 2g. What about the time of flight? Again, it's a 2 into uy divided by g, so that can be written as 2 multiplied by u sine theta, that is in our case it's a v2 sine theta divided by g. I hope these things are clear. Is it clear? Is it? Okay. Now let's suppose the situation is something like this, that this is one of the trolley and it is moving. It has been tied with rope and it is moving in this direction with speed v1, and you are going to project certain thing with speed v2 while making an angle theta with the horizontal. So it is continuously moving in this direction with speed v1. Suppose let's say that this bag or this box is being kept in the helicopter and that helicopter is moving in upward direction. So what you are supposed to do, you are supposed to do something like this. It's a v2 cos theta, this is v2 sine theta. Now in this case my range will be, what should I write? It's a range which can be written as 2 into ux into uy divided by g. This is equals to 2 multiplied by ux. Ux is v2 cos theta multiplied by uy. Now uy, it's a combination of two components, which is v1 and v2 sine theta. So this can be written as v1 plus v2 sine theta, v1 plus v2 sine theta divided by g. This is the range. Now what about the hmax? How could I write this? It's an hmax which is uy square divided by 2g. So this is v2 sine theta and v1, it's a v1 plus v2 sine theta whole square divided by 2g. And what about the time of flight? It's a 2 into u of y divided by g, which is 2 multiplied by v1 plus v2 sine theta divided by g. It's a 2u sine theta by g. I hope those things are clear. Is it clear? Yes. So this is very important topic, and this is the very important concept that we have not discussed in our regular classes. Yes. So please note this in your book. This is very essential topics and concepts. So let's look at the next question. What does it says? It says a ball projected from ground at an angle of 45 degree just clears a wall in front. Okay, if point of projection is 4 meter from the foot of wall, this is 4 meter, and ball strikes the ground at a distance of 6 meter. Okay, the height of the wall is, if you remember, we have derived this relation y is equals to x tan theta into bracket 1 minus x by r. So here y is the height of the wall, x, it is this location, it is a 4 given, tan theta, theta is 45, so this is 4 into tan of 45 degree into bracket 1 minus x, it's a 4. Now range, what is range? It is starting from here and it is ending up at here, so it's a 4 plus 6. This is the range. So this is 4 into tan 45, which is 4, 1 minus 4 by 10. So this is equals to 4 into bracket 1 minus of 0.4. This is 4 into 0.6, which is 2.4 meter. That's it. You did it. Great job. Is it clear? Is it clear? Great. Any issues? No? Let's have a look to the next question. Do it quickly. What does it say? It says a projectile is given an initial velocity of I plus 2j meter per second, where I is along the ground and j is along the vertical, and even they have given that take g is equals to 10 meter per second. What they want? They want equation of trajectory. So how can you do this? you have been given that u is equals to I plus 2j. This can be written as ux in I cap plus u of y in j cap. So if I write this, it is ux, which is a u cos theta given a I, and uy, which is a u sin theta, that is given as a 1. Sorry, u sin theta has given a 2. So equation of trajectory is required. I can write like this. It's a y is equals to x tan theta minus of half into g x square divide by u square cos square theta, and the data given is ux is 1 and uy is 2. That is ux equals to 1, uy is equals to 2. Now what I want, first I want tan theta. So ux is u cos theta, uy is u sin theta. So let's take a ratio of this. It's a u sin theta by u cos theta. It is a tan theta, which is equals to 2 is to 1. So this is value of tan theta. This is y is equals to 2 into x minus of half multiplied by g. G is the 10 multiplied by x square divide by u square cos square theta. It is a square of this. It's a 1. So this is equals to 2x minus 2 into 5. It's a 5x square. This is equals to y. That y is equals to 2x minus of 5x square. What was your answer? What was your answer? It is this. Is it same? Is it? Well done. Great job. Keep this, continue. And let's find it out the next question. The question is, a particle is moving with velocity of ky I cap plus kx j cap, where k is the constant, the general equation for its path. Okay, so how can you do this? How can you do this? So what you need to understood is that v is equals to, this is ky and kx. That means they have given vx, which is equals to ky, and vy, which is equals to kx. So this is the velocity, and for equation for its path you need to find out, you need to reach to the x and y. That means from vx to x and from vy to y you need to integrate. Yes, great, you understand it correctly. So from to reach from vx to x you need to integrate it, from vy to y you need to integrate it. Let's have a look. That vx, that is equals to dx by dt, which is ky. So if I write like this, it's a dx by ky, which is equals to integration of dt, and dx by ky, which is equals to x by ky, equals to integration of dt. Same way dy by dt is equals to kx, so which is dy integration of dy by kx is equals to integration of dt, and this is y by kx, which is equals to integration of dt. So from 1 and 2 I can equate this to x by ky is equals to y by kx, and according to this it's a kx square equals to ky square, or I can write like this, it's a y square is equals to x square plus constant. Is it clear? Is it? Great. Let's have a look to this next question. Let's have a look at this. What does it say? It says a particle is projected at 60 degree to the horizontal with a kinetic energy of k. Okay, the kinetic energy at the highest point, the situation is something like this. You have launched this object with a speed of 60 degree at an angle of 60 degree with a speed of u, sorry, and initially kinetic energy, it is equals to half mu square. At maximum height you are having an velocity which is a u cos theta, and uy, or I can say vy, is equals to 0 at maximum height. So your kinetic energy will be half mu square cos square theta. Put up the value of cos square theta. It's a theta is given, which is a 60 degree. It's a cos square of 60. Cos square 60, it's a 1 by 4. So this half mu square, it is the initial velocity kinetic energy. It's a k by 4. This is equals to the final kinetic energy. Is it clear? Is it? What was your answer? Is it same? Great. Look at the next question. Look at this. If a ball is thrown from a point with speed v0 at an angle of projection theta, okay, from the same point and at the same instant, a person starts running with a constant speed of v0 by 2 to catch the ball. Will the person be able to catch the ball? If yes, what should be the angle of projection? The situation is something like this. That ball has been thrown with speed v0 while making an angle theta. At the same time, you have started running on the straight path, obviously, with a speed of v0 by 2. Now the question is that whether you can catch the ball. If yes, what should be the angle of projection? So what is the concept behind the relation is that this is v0, this is v0 cos theta, and this is v0 sin theta. Person is going to run on the horizontal plane. So if at a certain time distance traveled by the ball and distance traveled by the person is same, then you are about to reach the ball. That means distance traveled by person, let's say it's a v0 by 2 multiplied by t, and distance traveled by the ball, it's a v0 cos theta into t. If I equate this, if I can equate this, that at the same time, at this point of time, both, that means the ball and the person would be at the same position. So let me equate this. It's an xp is equals to xb. If I equate this tt has gone, and I'm left with the v0 cos theta, that should be equals to v0 by 2. This v0 has gone. That means cos theta is equals to half, and this half, that means theta is equals to 60 degree. That means if ball has been thrown with 60 degree while with the horizontal, then a person can catch the ball definitely. I hope those things are clear. Is it? Is it clear? A very good question. Highly conceptual. Good. Next question. Look at this. What is the question? Yes, it says a projectile can have the same range. What does it mean? Same range for two angles of projection. That means one of the object has been thrown with theta 1 equals to theta, while another is theta 2, which is equals to 90 minus of theta. So one of them might thrown with theta, and while another will be thrown with 90 minus theta. If t1 and t2 be the time of flights in these two cases, then the product of the two time of flights is directly proportional to t. This is the same question that we have did in our sessions of projectile motion. If you are not aware with this, please go through this lecture. Yes, so let's begin. It's a angle 1, it's a theta 1 equals to theta, and angle 2, that must be is equals to theta 2, that must be equals to 90 minus theta, because if this is the case, then range 1 and range 2 would be equal, r1 equals to r2. So this is t1, which is equals to 2u sin theta by g, and this is t2, which is equals to 2u sin 90 minus theta, it's a 2u cos theta by g. Yes, so let's just multiply this. It's a t1 into t2, and it's a 4u square sin theta into cos theta divided by g into g, it's a g square. So let's keep this as a aside, and u square sin 2 theta by g, it's a range. This is range. So this is 2r by g. What other relations were related when this question was discussing. The one of the relation was R1 equals to R2 because theta 1 plus theta 2 is 90 degree. Yes, the time of flight of 1, the time of flight of 2. It's a 10 theta. It's a sin theta by cos theta. You can check this. T1 into T2 that we have just derived, even derived at that point of time. It's a 2R by G. H1 is 2H2 that is equals to sin square theta by cos square theta, which is a 10 square theta. If you are not aware with this, again go through that lecture. One more, it's a R should be is equals to 4 under root of H1 H2. You must aware with all this. This all are related with this question. This if theta 1 plus theta 2 is equals to 90 degree, then this all relations are correct. You must know this. I hope these things are clear. Is it clear? Let's have a look at the next question. What does it says? It says that a boy playing on the roof of a 10-meter high building throws a ball with a speed of 10 meter per second at an angle of 30 degree with the horizontal. Okay. How far from the throwing point will the ball be at a height of 10 meter from the ground? How far from the throwing point will the ball be at the height of 10 meter from the ground? This is what you require. Now tell me, how could you do this? How could you do this? What all is given? That initial velocity is given, that is of 10 meter per second. An angle theta is given. This is the angle theta is equals to 30 degree. Now what I want the range. It's a u square sine 2 theta by g. This is u square, this is 10 into 10 100 multiplied by sine 2 theta. It's a 2 into 30, it's a 60 degree, divide by g. So this is 100 multiplied by sine 60, it's a root 3 by 2 into 10. If I solve this, it's a 8.66 meter. What was your answer? What was it? Did you get the same answer? Great. Let's look at the next question. Let's have a look to this question. What does it says? Let's have a look. It says that a body of mass m is thrown up vertically up with velocity v1 reaches a maximum height h1 in time t1, and another body of mass 2m is projected with velocity v2 at an angle theta, and the second body reaches a maximum height h2 in time t2 seconds. And if they says it's a t1 is equals to 2t2, then I need to find out the ratio of h1 is to h2. So one has been thrown in vertically upward direction, and the another is thrown with angle theta, something like this. So this is the situation. This is the first situation, and this would be the second. So if I write this for the first situation, I can have h max is equals to u square by 2g. Here my u is the v1 square, so I have written it is as an v1 square by 2g, and its time of flight, it's a u by g, that is a v1 by g. What about the h2 that has been thrown with an angle theta? It's an h2 is equals to v2 square sine square theta by 2g, and their time of flight, it's a 2u sine theta by g. It's an t2 because here it delivers to the maximum height only, so it is a v2 sine theta by g. Now according to the data they have given that t1 equals to 2t2. So t1, it's a v1g is equals to 2 multiplied by v2 sine theta by g. So if I solve this has gone, and v1 by v2, which is equals to 2 sine theta. Now let's take a ratio of h1 is to h2. h1 is v1 square by 2g, h2 is v2 square sine square theta by 2g. If you take out the ratio, put the value of v1, which is a 2 sine theta, you will get it's a 4. So this is the answer. It's a 4:1. I hope it is clear. Is it? What was your answer? Is it same? Great. Let's work for the next question. let's look at the data. What does it says? It says that a particle aimed at target projected with an angle of 15 degree with horizontal is short of the target by 10 meter. If projected with an angle of 45 degree is away from the target by 15 meter, then the angle of projection to hit the target. So the situation is that, let's suppose, once it has been projected with an angle of 15 and maybe a target was here, and this is short by 10 meter, and this angle was 15 degree. This angle was the 15 degree. Another, if projected with an angle of 45 degree is away from the target by 15 meter, that means the situation is something like this. This is the angle which is a 45 degree, and this is away from this, it's a 15. You need to find out an angle so that it can hit the target, something like this, and this is what we require. That means this angle of projection is required. So in this first situation, it's a range minus 10, it's a r minus 10, that should be is equals to u square sine 2 theta by g. Second relation, it's an away from the target by a 15 meter, so it would be an r plus 15 is equals to u square sine square or u square sine 2 theta by g. Yes, by solving it I can have that range should be equals to 35 meter. So let's check it out, that what should be the angle to hit at 35 meter from the origin. So I can write like this, it's an r is equals to u square sine 2 theta divided by g. The range would be equals to 35. This is equals to u square sine 2 theta by g, and let's put up the value, and if I get it done, it's a u square by g, that should be is equals to 50, and that should be is equals to a sine 2 theta. So if replace the value, that sine 2 theta is equals to 7 by 10. So if sine 2 theta is equals to 7 by 10, my theta could be equals to, it's a 1 by 2 sine inverse of 7 by 10. I hope this is clear. Is it clear? Great. So can you do this? Are you sure? Can it be done? Great. Let's move to the next question. What does it say? It says that three bodies A, B and C are projected with the same initial speed. Look at the same initial speed with angle of projections 30 degree, 45 degree and 60 degree respectively. The body or the bodies having the same range. Yes, the range will be maximum. Range will be maximum if theta is equals to 45 degree, that we know. So the object that has thrown will be having maximum range if it has been projected with the 45 degree, 45 with vertical or 45 with horizontal. Yes, I hope these things are clear. Yes, so this is the answer. Okay, now let's understood one more question from here, that let's suppose in the previous question find out relative value of R1, R2 and R3. That means R1 is the range when it has been projected with 30 degree. R2 is the range when it has been projected with 45 degree, and R3 is the range when it has been projected with 60 degree. So I need to just check it out, that which value having a maximum value, which having the next to the maximum, and which one be having a list. So if you observe this carefully, this is the maximum value that we know, because it has been thrown with an angle of 45 degree. Now from maximum, this is having a variation of 15 degree. It's a minus of 15 degree, and this is having a variation of 15 degree. So in reality, R1 and R3 would be equals. Yes, R1 and R3 would be equals. You can even check that it's a theta 1 plus theta 2, which is a 30 plus 60, which should be a 90. That means if an angles are complementary to each other, the range would be the equal. So what I can write like this, it's an R2 must be greater than R1 and R3, but R1 and R3 are the same. R1 and R3 is the same. Is it clear? Is it? So ready for the next question? Let's have a look what the data is saying. It's an object is thrown towards the tower, which is at a horizontal distance of 50 meter with initial velocity of 10 meter per second and making an angle of 30 degree, with the horizontal. The object, the tower at certain height from and bottom of the tower where the object hits the tower. Yes, you want to find out that where from the bottom of the tower it is going to hit the tower. So a situation is similar to something like this. This is the tower, and from here object is thrown towards this tower. From here you have thrown this from 10 meter per second while making an angle of 30 degree with the horizontal. Yes, it might hit somewhere here. You require this. I hope these things are clear. Is it? So let's have a look. What does it say? It's an X which is away from the something like this, the situation. It's a tower and this has been thrown. This is the 30 degree. This is the 30 degree, and they says that it is a 50 meter away. This is 50 meter away from the point of projection. So this X is equals to u cos theta into t, and value of X should be replaced by 50. So this is equals to 50 is equals to u, that is a 10 multiplied by cos theta. Now what is the value of cos theta? It's a cos of 30 degree. So cos 30, it's a root of 3 by 2 multiplied by t. So what I can have, it's a t that should be is equals to 10 by root 3 seconds. You required a y of this situation. We can write like this. It's a y is equals to u sin theta t minus of half into gt square. So let's replace the value. U is u sin theta, it's a 550 root 3 into t minus of half into gt square. So if I solve this, I can have this value. Can you do this? Yes. Can it be? Can it be done? Are you sure? Can it be? Great. Shall I add something to this? Shall I? That in the previous question, find out velocity of an object when it hits the tower. Now it was like this. So when it hits the tower, it will be having a two velocity. One is vx, one is vy. How can I have vx? The vx could be written as u cos theta because it never changes. Yes. Now what is velocity? It's a 10. and theta it's a 30 degree, so this is equals to 10 into cos of 30 degree, which is cos 30, it's a root 3 by 2, so this is 10 root 3 by 2. This is Vx. What is Vy? It's a u sine theta minus of gt. This is equals to 10 multiplied by sine of 30 degree minus of g. It's a 10 multiplied by time. The time is 10 by root 3. So this is equals to 10 into half. It's a 5 minus of 100 by root 3 seconds. This is Vy. And what would be the V? It's under root of Vx square plus Vy square. So is it clear? Is it? Can you do this? Can it be done? Are you sure? Great. Let's have a look to the next question. Do it quickly. It says that a body is projected horizontally from the top of a tower with a velocity of 10 meter per second. If it hits the ground at an angle of 45 degree, the vertical component of velocity when it hits the ground in meter per second, you are finding out vertical component according to the data given. It's a tower that has been thrown horizontally. Maybe it is going to be delivered at here, yes, and this will make an angle of 45 degree with the vertical. So what is required? It's a 1045 that can be written as Vy by Vx. I know that 1045 is 1 Vy, and Vx, that is the horizontal velocity which never changes throughout the journey, it's a 10. So Vy can be written as 10, and that's it. You did it. Great. Very easy, you know. Yes, great. That in the previous question find out velocity when it hits the floor. So this was the situation. You have thrown like this, and when you throw like this, that this was the 45 degree and this is the V. So while I calculate V, I should add up. This is Vx square plus Vy square. What is Vy? It is 10. What is Vx? It is the 10. So that should be equals to under root of, this is 10 square plus 10 square, that should be equals to 10 root 2 meter per second. I hope these things are clear. Yes, yes, is it clear? Is it? Great. Now let's move to the next question. Do it quickly, do it fast, do it quickly. What does it given? It says that a body is projected with an angle theta. The maximum height reached is h. If the time of flight t is equals to 4 seconds and g is equals to 10 meter per second square, then the value of h. Okay, so what does it say? It's a time of flight which is 4 seconds. So time of flight can be written as 2u sine theta by g, which should be equals to 4. That means if I replace the value of g, which is a 10, it's a 2 2s are 4, 2 into 10, it's a 20. So that I can write it's a u sine theta, which should be equals to 20. And h, it's a maximum height, it's a u square sine square theta. H max, it's a u square sine square theta divided by 2 into g. you have a value of u sine theta which is equals to 20, so this is equals to 20 square divided by 2 into 10. And if I solve this, it's 400 divided by 2 into 10, 20. This 2 has gone and this is 20 meter. Did you get the same? Did you? Great. So can I move to the next question? Shall I? Great. Let's have a look. What does it says? It says that the path of a projectile is given by the equation this is y is equals to ax minus of bx square, where a and b are the constant and x and y are respectively the horizontal and vertical distances of projectile from the point of projection. The maximum height attained by the projectile and the angle of projection are respectively. Okay, so this is equation of trajectory. What they have given, it's a y is equals to ax minus of bx square. So this is the data they have given, that this is y is equals to ax minus of bx square. Now let it compare with the equation of trajectory, though that is equals to y is equals to x tan theta minus of half divided by multiplied by gx square divided by u square cos square theta. So if I compare this, here it's an x, so I can write like this, it's a tan theta that should be equals to a, and according to this theta is equals to tan inverse of a. What is you required? An angle of projection, and here is the answer. One more thing, what is value of b? It's a b is the g divided by 2 into u square into cos square theta. That is the b. Now let's find it out. The value of a square by 4b. So if I trying to do this, it's a square, it's a tan square theta divided by 4 into b. That what is the value of b? It's a g divided by 2u square cos square theta. So let's replace the value of this. It's a 4 into g multiplied by 2 into u square into cos square theta. So this tan square theta, which should be equals to sin square theta by cos square theta, multiplied by 2 into u square cos square theta. So this is 2, this is 2, this is 2. Yes, so that should be equals to a square by 4b, can be written as square by 4b. And this is sin square theta by cos square theta. Here it's a cos square theta, here it's a cos square theta. So the remaining term is u square sin square theta by 2g, which is equals to h. So h can be written as a square by 4b. Is it clear? Yes, you must remember this formula. This h is equals to a square by 4b. This is very helpful. Very helpful. Please remember this. Yes. Now one more question based on this only, that in the previous question find out range of projectile data given. It's a y is equals to ax minus of bx square. So when I say it's a y is equals to ax minus of bx square, something like this, may be projected with certain angle theta. So if this is the situation, that it has been projected with certain angle theta, then what I can see is that from here to here, this is the range of a projectile. This must be the range of a projectile, and when I consider it's a range, I can see this, that y will be 0. That means displacement on y axis will be 0 when I am getting the range. So this should be a 0. That could be equals to ax minus of bx square. And while this is the situation, I can have two value of x. That's a 0 is equals to x into bracket a minus bx. So either x would be equals to 0 or or a minus of bx could be equals to 0. So this is equals to a equals to bx, and which can be written as x equals to a by b. I hope these things are clear. Yes, yes, this is very very important. Please remember this. Very very important. Yes. Okay, great. Let's have a look to this question. What is data? It says a body is projected at an angle theta so that its range is maximum. That means it must be thrown with an theta of 45 degree. Now, if t is the time of flight, then the value of the maximum range is, yes, if the t is the time of flight, then value of maximum range. Here you require all the answers in terms of the t. So as they says, range should be a maximum. I know that it's a theta should be equals to 45 degree. Now let's write it down the time of flight. It's a 2u sine theta by g. This is 2u divided by g into sine theta. It's a sine 45, and sine 45 can be written as 1 by root 2. So this is 2, this is root 2, which should be written as root of 2u by g, and according to this it's a u which can be written as gt by root 2. Now you required Rmax, maximum range, and that maximum range can be written as u square by g. Yes, let's replace the value of u square. It's a g square t square by 2 divide by t. So this g has gone, and this is equals to gt square by 2. Yes, this would be the answer. Is it clear? Is it? Great. Ready for the next question? Ready? Let's have a look. Look at the question. What does it say? It says the velocity of a projectile at the initial point A from here. It's a 2i plus 3j meter per second. Its velocity at point B is, yes, it's a 15-second question. So this is point A, where this would be the initial velocity in Vx. This would be the initial velocity in Uy. Now when it landed up here, its velocity will be equals to Vx, and here it's in Uy. The difference is that this Uy was positive, this Uy could be a negative, and it would be a negative. But ux, and or you can say it's a vx, which remains the same. So horizontal component will remain 2, vertical component will remain 3, but as it is in negative x direction, it should be in minus 3. It's a 2i minus of 3. That's it. Yes, got it? Got it? Are you sure? Next, that in the previous question, find out first range. So the data given is that u should be is equals to 2i cap plus 3j cap, and this can be written as ux of I cap plus uy of j cap. That means ux, which is 2, uy, which is 3. So range can be written as 2 multiplied by ux multiplied by uy divided by g. It's a 2 multiplied by 2 multiplied by 3 divided by 10, which is 2 2s are 4, 4 3s are 12, 12 by 10. It's 1.2 meter. Yes, is it clear? Is it? Great. Shall I add something? Second, you required an Hmax. Now, what is Hmax? It's an u square sine square theta divided by 2g. Yes, so here this is uy, which can be written as u sine theta. So this is h max, which can be written as uy square divided by 2 into g. So uy, it's a 3. It's a square of the 3. It's a 9 divided by 2 into 10. It's a 20. So this is h max, which can be written as 9 by 20 meter. Is it clear? This is the value of h max. Is it clear? Great. Third, time of flight. So time of flight can be written as it's a 2u sine theta divided by g. And when I write it's a 2u sine theta by g, this u sine theta, it's a uy, that means 2 into uy divided by g, which could be written as uy. It's a 3. So this is 2 into 3 by 6 divided by 10. It's a 6 by 10, which is 0.6 time of flight. It's a seconds. Is it clear? Yes. So please remember this. Please remember this. These are the basics, and these are very essential questions. Yes. Let's look at the next question. This is the question that we have covered in our class as well. That it says that a particle is projected from the ground with an initial speed of v at an angle of projection theta, and you need to find out the average velocity of the particle between its time of projection, that means from this location, it is at point A, and time it reaches the highest point, this is point B. Yes, you need to find out the average velocity between these 2 points. It's in time of projection and time it reaches the highest point of trajectory. So we have did it from one of the approach, where you can calculate it, that at position A what is the velocity, at position B what is the velocity. I am talking about the UA and UB. Yes, this is equals to u sine theta, sorry, it's a u cos theta I cap plus u sine theta j cap, and u at B, it's again u cos theta I cap, and then V, which is equals to UA plus UB divided by 2, and things will be done. This is the approach that we have already used in this numerical for to get it done. Yes, this is just the different approach. Let's have a look. What I can write, it's an average velocity, which is displacement by time, and the displacement I have mentioned it at s. It's a displacement, it is equals to s by t. So now what is s? If you can observe this carefully, it is the situation. This is half of the range, and this is of h max value, and this is s. So I can write like this, it's a s, which is equals to under root of h square plus r square by 4 according to the Pythagoras. Now h, it's a u square sin square theta by 2g, and range is equals to u square sin 2 theta by g. And if I put up the value, it's a t, then you can observe that this is the position where it would be at the highest point. That means it's a time of ascent, and time of ascent can be written as u sine theta by g. So let's replace the value. Now if I replace the value here, it's an under root of h square plus r square by 4 divided by t. Then I can have that V average is equals to V by 2 multiplied by under root of 1 plus 3 cos square theta. Is it clear? Is it clear? Are you sure? So can it be done? Can it be? Yes. Great. Now let's look at the next question. According to the question, a body is projected with an angle theta to the horizontal. Okay. First, its velocity is always perpendicular to its acceleration. Second, its velocity becomes 0 at maximum height. At maximum height, it is not 0 because at maximum height, it is there. It's in u cos theta. At maximum height, only the y component of velocity is 0. Next, its velocity makes 0 angle with the horizontal. At its maximum height, its velocity makes 0 angle with the horizontal. So look at this. This is the direction of velocity u cos theta. This is the horizontal component, and it makes an angle of 0 degree with the horizontal. If they have asked at this point that velocity is making an angle of 90 degree with the acceleration, so it is the situation, because here only u cos theta would be there because vy is 0. And one more, it's at the body just before hitting the ground. The direction of velocity coincides with the acceleration. So this all are the incorrect conclusion. Only the third would be the correct one. So my answer to this question should be the third option. I hope these things are clear. Is it clear? So let's look at the next question. Let's have a look. What does it say? It says a body of mass 2 kg is projected from the ground with a velocity of 20 meter per second at an angle of 30 degree with the vertical. 30 degree with the vertical. Please take a look. It's an angle of 30 degree with the vertical. If t1 is the time of seconds at which the body is projected, and t2 is the time in seconds at which it reaches the ground, okay, the change in momentum during the time. Yes, so this is the situation. Y-axis, x-axis, and it has been launched from here and it has been delivered here. So it's in u cos theta. This is u sin theta. Again, this is u cos theta. This would be the u sin theta. So if I'm going to find out the delta p, then I can have it's in u sin theta and u sin theta. This is going to be at, which is in a mode of 2m u sin theta, and this u cos theta has gone. So let's put up the value, but while replacing the value, they have given that it has been projected with an angle of 30 degree, but that 30 degree has been given from vertical, and you need to convert that with respect to horizontal. So this would be equals to 60 degree, and let's just replace the value. It is 2 into m into u into sin theta. Theta would be equals to 60 degree. So this is equals to 2 multiplied by 20 into sin 60, which is root 3 by 2, which should be is equals to 40 root 3 kg meter per second. I hope these things are clear. Is it clear? Are you sure? So let's have a look to the next question. Let's have a look to this question. Have a look what the data is saying. It says that a body is projected from the earth at an angle of 30 degree with the horizontal with some initial velocity that we don't know, and if its range is 20 meter, the maximum height reached by it. You might remember that we have derived this relation in our classes. It's an r by h, that should be is equals to 4 by tan theta. So the range is given, which is of 20. H is required. 4 divided by tan 30, it's a 10 of 30 degree. Let's replace the value and get the answer. Yes, it's a 20-second questions. I hope those things are clear. Is it clear? Yes. Like to do a same question. That means the question based on same concept, that if range covered by a particle is 4 times. It's 4 times the maximum height of a particle. Find out angle of projection. So how can you do this? Again same thing, it's an r by h. That should be is equals to 4 by tan theta, and according to the data, a range covered by a particle is 4 times the maximum height. It's a 4 by h. Divide by h is equals to 4 by tan theta. This h has had gone, this has gone, and that means tan of theta should be equals to 1. And when it says tan theta is equals to 1, it means theta is equals to 45 degree. I hope this is clear. But for this to do in fractions of second, this is required, that r by h is equals to 4 by tan theta. I must remember this. If I am knowing this, it would be much easier to do this. Is it clear? Great. Let's have a look to this question. What does it say? It says that the equation of trajectory of a projectile is y is equals to 10x minus 5 by 9 of x square. The maximum height. I hope you remember this, that if I replace this, or if I compare this with y is equals to ax minus of bx square, my a would be equals to 10 and my b would be equals to 5 by 9. And I have told at that point of time that please remember this, that h max could be written as a square by 4b. H max would be equals to a square by 4b. Let's just replace the value and get the answer. Again, it's a 45 meter would be the answer. What was yours? Is it same? Is it same? Great. Ready for the next question? Are you ready? Yes. So the question is, the horizontal and vertical displacements x and y of a particle at a given time t are x equals to 60 and y is equals to 80 minus 5t square. You required the range of a projectile. So for range, what do you require? It's a 2 multiplied by u cos theta, which is a velocity in horizontal direction, multiplied by u sin theta, which is a velocity in vertical direction, divide by g. This is the range. Its range is equals to 2 into u cos theta into u sin theta by g. So now what is given? The given data is x equals to 6 into t, which is x equals to u cos theta into t. That means u cos theta is given as 6. Next, it's y is equals to 8t minus of 5 into t square, which is equals to y is equals to u sin theta t minus of half gt square. And if I compare this, it's a u sin theta which is equals to t, 8. So this is range. That should be is equals to 2 multiplied by u cos theta, which is 6, multiplied by u sin theta, 8, divided by 10. It is the same thing that I did here. So the range would be equals to 9.6. Yes. Is it clear? One more question based on this data only, that in the previous question find angle of projection with horizontal. You need to find out the angle of projection. How can you do this? according to the data, the x is equals to 6 into t, and y is equals to, it's 80 minus of 5 into t square. What do you want? Angle of projection. What is it? It's in uy divided by ux. So basically you are having an x and you required an velocity. So displacement is given, velocity is required. How can you do this? Yes, you know that you required an help from the differentiation. So let's do it. That ux, that is equals to dx by dt, that would be equals to 6. Uy, that is equals to dy by dt, and that should be is equals to d by dt of 8t minus of 5 into t square. This is equals to 8 minus of 10t. When you required uy, when you required an initial velocity, you need to put a t is equals to 0. So when I put t equals to 0, that would be, it's an 8 meter per second, and this is ux, which could be written as 6 meter per second. So this is equals to 8, this is equals to 6, it's a 4 into 2, it's a 3 into 2, and this has gone, which is 4 by 3. Now theta 4 by 3. Yes, remember the magic triangle, it's a 4, it's a 3, it's a 5. So if it is an angle between 3 and 5, its theta should be equals to 53 degree with the horizontal, and this should be the answer, that theta should be equals to 53 degree with horizontal. Got it? Yes. Ready for the next question? Let's have a look. What does it say? It says that the maximum height reached by the projectile is 4 meter. It is the maximum height. Okay. The horizontal range is 12 meter. Velocity of projection in meter per second is again the same thing. It's an r by h, that should be equals to 4 by 10 theta. So the range is 12. The h, it's a 4, that should be is equals to 4 by 10 theta. This 4 threes are, and according to this is 10 theta, which could be written as a 4 by 3. Now what do you require? You require a velocity of projection. Now you are having an range, you are having an h max. You can use any of the relation, such as here I have used the h, which could be written as u square sine square theta by 2g, and replace the value and get the answer. Even if you can use this, it's a range is equals to 2 multiplied by u cos theta multiplied by u sine theta divided by g. Even this can be done because you know the value of theta, and if you know the value of theta, you easily know it's an u cos theta and u sine theta, and get it done. Yes, this both options are correct, and whichever came to your mind at a priority basis, you should go with it. Is it clear? Is it? Great. So ready for the next question? Let's have a look what this question is saying. It says that two stones are projected with same speed, okay, but making different angles with the horizontal. Their horizontal ranges are equal, okay. So first angle is theta, another should be a 90 minus theta. Now what else they are saying? They says that the angle of projection of one is pi by 3, which is a 60 degree, and the maximum height reached by it is 102 meter. Then the maximum height reached by the other is required. Now what is given? The given data is the angle of projection of first, it's a pi by 3, it's a 180 by 3, which is 60 degrees. So other must be 30 degree, because addition of both the angles theta 1 plus theta 2 must be a 90 degree. Now you have been given h max, so what you can do, it's an h is equals to u square sine square theta by 2g. So let's have a ratio of this. It's an h max is equals to u square sine square theta by 2g. U square by and 2g would be a cancel out. Only the term that remains is sine square theta. Yes, because u is the same, 2 into g is always same. So this is h1 by h2. It's a sine square theta 1 by sine square theta 2. And if I put up the value, it's a sine square 60 plus sine square 30. I have been provided with the value of an h1 which was 102, and if I solve this, I can get this. It's a h2 which should be equals to 34 meter. Is it clear? Is it clear? Are you sure? Yes. Even you can take a help of this. That look at this. That h1 is given, and h2 is being asked. So if they have asked the range, you can have this. It's r is equals to 4 under root of h1 h2. t1 is to t2, that is equals to tan theta. You know the theta, you know the tan theta, and so on. Is it done? Is it? Great. Ready for the next question? Yes, let's have a look. What does it says? It says that the equation of motion of a particle is given by x equals to 3060 meter and 2y is equals to 9060 minus of 9.8 t square. The angle of projection is, yes, this is the same question that we have did it previously. Let's do it very quickly. This x equals to 3060, that means u cos theta is given, which is equals to 36. Now 2 into y is 9060 minus of 9.8 t square, that means y is equals to 48t minus of 4.9 t square. You can compare this with y is equals to u sin theta t minus of half gt square, as well as you can even do the same thing, that find it out the ux with the help of dx by dt, find it out the uy with the help of dy by dt, and here put t equals to 0 because you require initial velocity. So you can have a value of u cos theta, you can have a value of u sin theta, and let's just find it out. Tan theta, it is a u sin theta by u cos theta, which could be written as 48 by 36. Ultimately it is a 4 by 3, and from this tan theta should be equals to 4 by 3, but here no option is matching such as tan theta equals to 4 by 3. So I need to check it out for the value of sin theta. It is something like this, that tan theta, this is 4, this is 3, 5. So if tan theta is not matching with the answers, look for the other questions. If you look at the sin theta, it would be an 4 by 5 and things will be done. I hope these things are clear. Is it clear? Are you sure? Can you get it done? Can it be? Great. Let's look at this question. It is the same question. So this is for the do it yourself. Yes, it is the same question that has been asked again and again. So ready for the next question? Yes, let's have a look. What does it say? It says an object is projected with a velocity of 20 meter per second while making an angle of 45 degree with the horizontal. The equation of the trajectory is h is equals to a into x minus of bx square. H is the height and x is the horizontal distance. A and b are the constant. You need to find out a is to b. It's a ratio of a is to b. Yes. So how can you do this? It's what the data is given, that initial velocity u is given, which is 20 meter per second. Angle, it's a 45 degree, and this data, this h is equals to ax minus of bx square. So if I write down the equation of trajectory, then it would be y is equals to x tan theta minus of half into gx square by u square cos square theta. Let's comparing it with the a and b. Tan theta is equals to a. Now theta is given 45, so this is a equals to 1, and the value of B, it's a G by 2u square cos square theta. So here theta would be equals to 45 degree. So it's an, let's put up the value of theta equals to 45 and try to find out A is to B, which would be an 40 is to 1. Yes, easy, beat easy. Yes, is it clear? Is it clear? So will you be able to solve this? Will you? Great. Let's have a look to this question. What does it says? It says it is possible to project a projectile with a given speed in two possible ways so that it has the same horizontal range. Yes, the product of the time taken by the two possible ways, it's a t1. So this is only the possible, if you have thrown your object with theta 1 equals to theta and theta 2 equals to 90 minus of theta. Thus both are the case from the horizontal. Yes, so this time of flight, it's a 2u sin theta by g. The second, it's a 2u sin 90 minus theta, and this is equals to t2, that is equals to 2u cos theta by g. If you remember, this is the question that we have done in our class notes as well. It's a t1 into t2. If you are going to multiply this, it's a 2r by g. If you don't know that, please go through the class notes, again revise it and try to get it done as soon as possible. Yes, range, it's a 4 root of h1 h2. Yes, I hope this is clear. Is it clear? Great. Ready for the next question? Are you ready? Let's have a look. What does it says? It says that four bodies P, Q, R and S are projected with equal velocities. Look at this, it's an equal velocity having angle of projection of 15, 30, 45 and 60 with the horizontal respectively. The body having shortest range. So what you need to consider is that we know that range is equals to u square sine 2 theta by g. Each one is having the same velocity, that means u is same, g would be the same, so the range only depends on sine 2 theta. So if theta is small, range is small, so p must be having shortest range. I hope these things are clear. Even you can have one more approach to this. Let's have a look. That this are the four angles. One is 15 degree, another is the 30 degree, another is the 45 degree and another is the 60 degree. Let's call this as a range 1, this is a range 2, this is the range 3, this is the range 4. So this four ranges are there, range 1, range 2, range 3 and range 4. And this R3, it's a maximum range, this is the maximum range. So if I try to find it out, the variation from this maximum range, this is of 15 degree variation, even this is of 15 degree variation, and from maximum this is a variation of 30 degree. So higher the variation, lesser would be the range, because this is the maximum range. So you can even write like this, that your range 2 and range 4 would be an equal, and R3 would be the maximum, which would be followed by R2 and R4 because they are having the same value, and the least will be the R1. So even this is the approach, and this is very good approach. You don't require to calculate, or you don't require to write anything. Yes, this is just the mental calculation that can be done, and things can be done very easily and very quickly. Yes, so can you get it done? Are you sure? Great. Let's have a look to the next question. What does it says? It says the maximum range of a gun on horizontal train is 16 kilometer. if g is equals to 10 meter per second square, the muzzle velocity of the shell is required. So what did they say? It's a range maximum, it's a 16 kilometer, so it's a 16,000 meter. Or you can say that maximum is said, so theta is equals to 45 degree. So R max is given, it's a v square by g, which is equals to 16,000 is equals to v square by 10. So v square is equals to 16 into 10 to the power 4, and v, muzzle velocity, is required, which is a 400 meter per second. So you can do it very easily. You can do it very easily. If they have asked, find out the h max. It's a u square sine square theta by 2g. Now you are having an u as well. Theta is there. So you can just calculate it using h max, which is equals to u square sine square theta by 2g. I hope those things are clear. Is it? Is it clear? Are you sure? Great. Let's just wind it up this session over here. This is all about the previous year asked questions of motion in a plane, and this is the last and final class of the motion in a plane. So please revise this unit, motion in a plane. Yes, because this is just a combined package. It's a motion in a straight line and motion in a plane. It's a motion in 1D and motion in 2D. Yes. So if you practice a lot, this will help us to score good numbers in motion in straight line and motion in plane. Thank you. Have a good day. Take care. Bye bye.